So problem 29.25 explains that a magnetic resonance imaging needs a magnetic field strength of 1.5 Tesla, and the solenoid that's used is 1.8 meters long, 75 centimeters in diameter. It is tightly wound with a single layer of 2.30 millimeter diameter superconducting wire. So the first thing when you're thinking about this problem is just writing down what you know and drawing the picture. So this is just going to be a standard solenoid, and as the problem explains, they're using the solenoid for the technology so as to have a fairly uniform magnetic field inside of this cylindrical type of shape. So in order to accomplish that, there's going to be some current that is running through this, the coiled wire on the outsides of this. So our equation that we're going to be using for this is derived from Ampere's law, I believe. It is in the book, but it is generally just a given equation that the magnetic field for a solenoid, is U naught times N times I over L, where N is the number of turns of the coil. So looking at what the problem tells us we know, and the picture, which basically from the picture we can treat this mostly like an ideal solenoid situation. So we see that the only unknown we have right now in our equation is N. We don't know how many numbers of turns there is, but because of the fact that they gave us the diameter of the wire and the length, we can solve for that. So N is just going to be the length of the solenoid divided by the diameter of the wire. And that makes sense when you imagine in your head, because across the length of that solenoid, each wire has some distance straight across, and as those wires are wrapped around to be extremely close to each other, essentially touching, you can make this connection in order to solve for N. So remembering to convert our units, we get a total of 782.6 turns for the solenoid. So continuing on, we need to solve, or essentially just transform our equation somewhat, so we're solving for I. So once you do that, rearranging things, you get that the current in our solenoid is that magnetic field strength times the length of the solenoid over N times U naught, which is obvious, or not obviously, but it's that standard constant. So all you have to do is plug in the numbers, getting and remembering to check all your units. And for this part, I'm pretty sure all the units are good. We get a total of 2,745 amperes of current that are going to be in this solenoid in order to have a magnetic field strength of 1.5 Tesla. And once again, that magnetic field strength is inside of the coil, I'm fairly sure. So that's pretty much it. The problem's not too bad. It can be a little bit tricky to figure out how to get in, maybe. You might not make that connection initially, but once you get that, it's pretty much as simple as just plugging things in. But yeah, that's pretty much it. Thank you for listening.